How you doing, everyone? So I'll just say a few words then. For those of you that don't know me, my name is Barry Crumford. I'm the founder and one of the organisers of the LJC. I actually founded it way back in 2007. Now I'm not a developer myself. I'm in fact a recruiter. I run a recruitment company called Vertx, which many of you may have heard of. So I originally set up the group as a way of trying to establish us as Java recruiters. My initial plan was to try and grow a group of maybe 200 or 300 people, and every now and then just say, hey guys, if anyone needs a recruiter, then here we are. But over the years, it's taken on a life of its own completely. So I think we've just had something like 7,500 members, and it is one of the biggest in Europe, and obviously behind Adopt Open JDK and a lot of the other initiatives out there that have grown. So yeah, it's become a pretty incredible thing. More than just the numbers though is a sense of community that we've always had and we've always maintained within the group. It really is a place where everyone comes together to help each other out and help each other learn and get further ahead on the path. We've organized over 600 events now, and that's 90% of them has been from LJC members speaking to other members, just trying to educate and help everyone learn. So there's opportunities there. If anyone wants to get involved and give other presentations, workshops, lightning talks, anything like that, then then talk to me and we'll see what we can do for you. And this tonight is an exact example of that. So I put a call out on the mailing list just saying, does anybody want to run any workshops or anything like that? Adam answered the call. Came through and yeah, it's signed up for giving this event. So thanks very much, Adam. If people don't know who Adam is, he's a full stack developer at Goldman Sachs. He's got over 6 years of Java experience building data analytics, tooling, and training systems. And with that, I'll hand over to Adam for the presentation. Enjoy.
Cool. Thanks a lot, Larry. Just to check, can everyone hear me okay? Yeah, cool. All right, yeah, welcome. So yeah, as Barry said, I've been meaning to engage with the LJC for a while. I've been to a few talks maybe a year or two ago, and yeah, I thought with the recent isolation, yeah, there was a shout out for Vertx, some knowledge share. So yeah, I've taken part in this. So I want to keep it quite interactive. So if there are any questions, please either put your hand up on the chat or just shout out. I'm happy to answer questions afterwards as well. So I will share my screen. So just bear with me. So I think that's the one. So you should be able to see my deck and the presentation. Is that right? Let me. Sorry, I've lost the Zoom.
Yeah, that's fine, Adam. We can see the deck. Yeah.
Cool. So I can't see you. I can hear you though. So if you shout out, yeah. Okay, cool. So as Barry said to begin with, my name's Adam. I've been at Goldman 6 years. I'm a full stack developer. I work in the systematic trading strategies team at Goldman Sachs. I've been a Java developer since I basically joined Goldman as a graduate. In my spare time, I've done a bit of Python, which maybe shouldn't say too loudly in this group, but I also do lots of Java, occasionally dabble in a bit of web, and I guess what I really enjoy is bringing them all together and building end-to-end solutions. Vertx is a perfect tool for that. In my spare time, I like to cycle. The weather's getting a bit better, so I've been able to do a bit of that as well. So I'll go through what Vertx is. Typical Vertx architectures. I'll give you some building blocks so you can build one yourself. I'll go through the raw components, so handlers, verticals, and how to deploy them. We'll go through a couple of REST methods, and then hopefully there'll be time. I can show you the code anyway. I'll see if I can build a live REST server, very basic one, with those components. And again, if time, we can maybe do some integration testing with the Vertx REST client. So without further ado, we'll go into the more technical. So for those of you who aren't familiar, Vertx is a framework that it does lots of things. My main use case I've used it for is network connectivity. So it enables you to wrap your APIs quite nicely and expose them via REST, WebSockets, or other network or TCP protocols. It's event-driven at its core, and that makes it very scalable. So you can delegate out these events into this, into clusters, or scale it horizontally. It's available in Java, Python, Go, and I think there's even some parts of it in JS. It works really nicely it's ideal for web development, really. And once you've got the basic things, you can spin up a nice server, a prototype, and then to scale that, you're already in the Vertx ecosystem, and it makes it really nice to play with. Okay, so I can quickly, just before we go into the depth of Vertx, so from a practical point of view, as I mentioned, Vertx is used for REST services. How we use Vertx at Goldman, well, we've got thousands of microservices. We have lots of data and functions. So we're actually, a quarter of our firm is technologists, and our business literally can't operate without the technology. So we're a key stakeholder in all in our business functionality. We have thousands of microservices, and we need APIs in order to keep our business scalable, resilient, and so that we can ultimately serve our clients. I've seen Vertx used in my career at Goldman. So a few examples. I've built a couple of data analytics platforms where we use that to monitor market data, provide insights to our traders and portfolio managers. We also use it for risk management. So I guess the key thing is access to data, or providing services to action upon that data. I could do a whole talk on this. I won't. I'll go away from maybe the functional side and go more into the deep technical now. But Vertx is extremely powerful, and it's really useful for us. So to go on to the key terms of Vertx. So this is how this is my understanding of it, and there might be a few different definitions that have changed over time, but these are broadly true. Ultimately, we start with a Vertx server, and this is what I think of as the main class. So does someone have a question? Okay, just shout if you need to stop. So we started with a Vertx server, which I see as the ultimate wrapper. And in that wrapper, we have what's called a vertical, and that's a component similar to a servlet. You can think of them as threads. That's essentially your runtime, the way you can run things. And Vertx scales out. So in this diagram I'll show you, you have multiple verticals. You can use event buses to communicate between them. But ultimately, everything in Vertx boils down to a handler. And the handler performs an action on a request or an event. So you run your handlers on a vertical, which makes it scalable. And your handler will obviously handle the request. So an example might be, you might have a get handler on an endpoint, and your handler code will live here. Another key concept, I'll go through these in a bit more depth, but these are the three key components you really need to know: vertical, handler, and router. Router will bind the path to the handlers. So you set up a router, you tell it that to listen to /my endpoint, and you register your handler with that. Another thing which I don't think I've got time to go into, but I briefly mentioned a second ago, was the event bus, and you can use this for sending events through the cluster. So this enables you to make things a bit more scalable, and it's really handy. Again, I'll go into a bit later, if you need to go off your vertical onto another one, or you need to communicate between, say, threads or processes. Any questions so far? Okay, cool. So without further ado, I can go on to how we build a handler. So we can start with a very simple example. So we won't bind it to a path just yet. We'll expect that we get a request in, and it's our job set to handle it. So I can share this later, but if you, just to get started, I've got this Maven project. I've got just Vertx Web client that I'll use later, and these dependencies just JUnit. Might use Mockito a bit later as well, and I use JSON to put it into JSON. So if I just create a new Java class called my handler, can just confirm you guys can all see this.
I've got it fine, Adam. I'm good.
Cool. Thanks. So yeah, we've got this handler. All you need to do is implement handler, and that takes in this routing context, which I'll explain in a minute. And then I'll just import that. So with this Vertx core, and then a handler literally just has a handle method, and that's all there is to it really. Once we're in here, we get this big object, the routing context. This routing context has access to basically everything and gives you everything you need to proceed as well. So it gives you access to the request, everything on the request, so params, headers, cookies. There's even a user object on there if you set it up. You can, it's really useful, and then you can use it to then create a response. So from the routing context, if I was just to say hello world, I grab the response, I literally just call this end method, and I can just put hello LG say in there. Another thing you might be familiar with, you can set the status code on there. So if you were to return an error or anything, you could put, say, a 400, but by default, it would be 200. So these are the basic concepts, and you just need to make sure you call, as I say, end on the end of it. So I'll just, yeah, progress there. So this is really simple. It's not very useful because it's literally just going to say hello world. But if we were to test this, I'm going to assume most of you are familiar with unit testing, so I won't live code this one, but we can use mock-in just the same as anything else. So we create a test subject, so your handler. You just need to mock out this routing context, mock out the response on the back of it, and you can use Mockito to kind of glue that together. So when this response is called, you get your mock response, and then when you call handle on that mock context, you can just verify that the end method is being called. So the design of this is very testable, and the design of this Vertx API is quite testable. So it means that from the get-go, you can use TDD to build your handlers, and then that makes it more scalable to kind of develop, and obviously more supportable in the future by testing this thing in isolation. Cool. Any questions before I move on to maybe making more use of this? Right. Cool. So I'll just move on. So verticals are the big, I guess the main component, the meat of learning about Vertex. So they're units of deployment in Vertex. You can think of them as like threads. They have an event loop on them, so they will handle in a single threaded way a request, delegate it to a handler via a router, perform something on there. And as you can imagine, as it's single threaded, if you've got dozens of requests coming in, you need to minimize your time there. So the golden rule is never block the event loop. That way you can continue serving clients whilst you're processing requests. And there's a couple of patterns I can go on later to make it easier. But for now, verticals typically do two things. Actually, they can do a lot more, but just for the purpose of this, they listen to events. So you can listen to them externally via the handler and router, and they process them. Or you could subscribe to an event bus and receive messages from other verticals or other components and process. I've put this in, I've talked about it already, but it's already here twice. Golden rule, as I say, never block the event thread. So, for example, as I said, if you need to handle 10,000 requests per second, you need to make sure that whatever you're doing in your handler only takes 100 microseconds or scalable that way, because otherwise you wouldn't be able to perform, get the performance of 10,000 requests per second. Another advantage to using verticals is you can treat everything as single threaded. So this is useful if you need to, you don't have to worry about race conditions or things like that. But it comes with a cost that, as I just mentioned, if you block the event thread, you can't serve client requests. So it's very simple to create a vertical. You just need to extend this abstract vertical, and similar to, I guess, like a runnable or like a thread, you just override the start and stop class, start and stop method. And in here, you could create a little HTTP server, bind your routers, bind your handlers, or you could create like a mesh of verticals and communicate between them. Or you could just subscribe to something else and start polling and listening. It's quite versatile in what it can do. So I guess it is so important that I put a whole slide on this, blocking the event loop. So I mentioned that as you're handling requests, you're going to be blocked in that handler. So you need to avoid things like input output. So any file or database reads, if you're doing that serially, as your client requests come in, you're now blocked going back to and from the database, and you can't serve the next request that comes in, which if in a high throughput system would be very often. Avoid complex calculations. Never call thread.sleep. And of course, if you're implementing your own thread safety functionality, you've got to be very careful that you don't have multiple verticals or threads in a deadlock, because then you can't serve your clients. So the idea is you make everything asynchronous, and you want to avoid this warning. Vertx will automatically monitor your event loop thread. And if it sees it's been blocked for 2 seconds here, you'll see this in your logs. So when you're debugging, you'll see this a lot. It's nothing to be alarmed by initially. But that, obviously, in the real world, some client requests will be expensive, and some client requests will require going to a database, because otherwise you can't do basic CRUD. So there are ways around it. You just need to bear this in mind. You can wrap everything with this execute blocking, which I've never personally used, but it gives you a promise, and you get a result handler back. Another way is to use a bunch of work verticals, and the worker verticals that you use an event bus to communicate with. So you have your vertical that just handles client requests. That then goes out to, say, another thread pool. And what you could do is you could handle, say, you could get the response here, or even the request, or even the routing context, push that to a worker in this handler, push that to a worker, handle the next one, push that next to another thread pool. And then when the thread pool is completed, it's got a grip on this routing context that's come through from the client, and it just needs to call this when it's done. And it can be done off the event loop. There's a couple of patterns for that. There's quite a bit there. Any questions before I move on to maybe a bit more of an example? I can't see the Zoom, so it seems to have gone off my my screen, unfortunately. But yeah, but just shout if you do. Okay, cool. So did someone? Oh, sorry, I've just seen your messages. I can definitely zoom the code for you. Just bear with me. My thing's frozen. My wall, I think, still not. Does anyone know the shortcut in IntelliJ? If you can put that on the chat, I can zoom in. So I've just seen the question, is Vertx similar to Wordflux? I don't actually know what Wordflux is. I've never used it personally. All I will say is Vertx is a similar pattern. So you do see some handler things in, I've seen it in some Spring Boot. Again, I'm not that familiar with it, but I can't really answer that whether it's familiar with Wordflux. Cool. Let me try presentation mode. I do remember this. There we go. That's better. I hope you can see that example now. So to go back to how we can use this in real life. So the next step will be we obviously want a HTTP server. So we've got we create this vertical, which we think of as our event loop and our thread. We can create a HTTP server very easily through here, and it obviously listens. But then that again is not doing much. So we're slowly building up the building blocks here. We've got a vertical, we've got our server. Now we need the actual logic itself and obviously the routing. So this is what we can use routers for. Routers direct requests to handlers, and you can chain them. So I can quickly come up with an example here. If I just change this class, and it's called my handler. I will rename that to, just while it's in presentation mode. So let's extend this abstract vertical. And then file. Cool. So we've got the start method. So we can create this router in Vertx, and the advantage of extending that class is we already have the access to the Vertx in here. Sorry, the API change. So it'll be yes, that's how we pass in the Vertx. I remember now. So we create this, and then what we can do is bind via this. So we can create a post. We can say /API my endpoint, and we can then put in new. So I create a new handler here. Sorry, the API is like that. Yeah, cool. So this is how we bind it. So anything that gets posted on that endpoint will automatically go to that handler. And as I just shown, that's how we can handle it. But the big advantage of routers is you can chain them. So I could subscribe to here, to API/star, and I can create one here, my endpoint. And what I could do in this handler is I could have an authentication handler. I could have a check handler. I can even put a login handler if I like. And it's quite nice. You can have this tree where you subscribe to API and then everything down, and you can nest it. So I've used this a few times, this pattern, just to so that we can authenticate everything on our API, which, as I work for a bank, is it's kind of crucial that we have good security even internally. Any questions on routers? I can actually see the Zoom group chat now, so feel free to ping them as well. Cool. So we've got maybe 10, 15 minutes left. What I can do is we can put all this together and create a very simple API. So I'm just going to exit the presentation mode, and I can show you some things. So I don't know if you can see, but I'm going to design and build a quick person, say a person repository or a catalog. So let's say we have two endpoints we want to implement. We have this post person and get person. So this will input it in, and we have a get person which will retrieve that person. For the store, we can just use a map. In memory should be fine. I know technically we shouldn't block the event thread, but you know, we'll be accessing the data in memory, so for this it should be fine. This is what I expect the API to look like. So we'll create a get person handler, so /API/person, where the first name we input there, the second name there as a query string, and we can post as well. So I've created this model before. So for those who can't see, it's literally a POJO with first name ID, second name, and email. And then I've created a person store, which I will zoom in on. So this is what I try to do when I'm building Vertx APIs. I try and build the core logic away from Vertx first. So the business logic, and I'll have these methods that Vertx can then interact with. And it just means that there's, well, one, it's testable. You don't need to rely on you know, Vertx methods to test. Two, if you do want to move away from Vertx, obviously it's or upgrade it, it's easier. So I've got this map of persons that I'm going to store. This is really trivial. This ID that I want to keep track of, an add person method, which just puts the first name, second name as the key and the person in, and then I've got this find person, which just retrieves it and returns an exception if it's not found. So I'll just come out of presentation mode there. Cool. So first thing we need to create is an add person, or let's say a find person handler. So again, we implement the handler. We have this routing context. And then I can just implement you've guessed it, handle. So I can show you how we can get the query parameters off of out of Vertx, out of the request. So again, the written request has absolutely everything. So from this request, you know, the cookies, the user, we can get the body from the request. We can do, you know, it's a one-stop toolbox essentially. You know, we can even get access to the Vertx instance that we have there. So I just need the request in this example, and I'm just going to get the param first name, and I'll do the same for second name. And one thing I forgot to do was just create a constructor of this. So obviously these handlers are going to have to share the person store. So that needs to be injected in. So I'll just create that. So we'll create this over there. So I've got the, see, I'll change that to second name. Got the first name, second name, and then all we literally need to do, because we've got this nice abstraction, obviously just find the person. Now I'm not accounting. Oh, I need to account for this this thing here. So if the person is not found, it will throw an exception. So I've got the person here. So I've got two cases here. Well, one that the person exists, I've got something to give back to the client. Obviously, another one, the person's not there. So yeah, how do we handle that in Vertx? So I also I'm going to need JSON in here. So I can create JSON instance. I'll just, ideally that's to be handed in, but I'll just create one here. And then to return, I just call response and this.json dot to JSON, the person. Oh, sorry, I'll go back to presentation mode. My mistake. Cool, I hope you're following. So we've got the first name, second name here that we extract from the request. We've got this person that we call from the API that I designed earlier. And to return it, I'm getting the response from the routing request, and then I'm calling end on this. And that's a successful case. But you know, a big thing with REST, well, with any API, right? You need to take into account the edge cases. So if that person is not found, then I need to return either an error. So here I could set status code to, I think it's 401, and then I call end on that. And it's as simple as that. Or I could put an error message in here that returns. And that's all there really is to it. You should obviously check whether the parameters exist and then handle that. If the first name's there but the second name's not, then maybe return an invalid request back to the client. Vertx enables you to do that quite easily. So in the interest of time, because I think we've got 5 minutes or so left, what I'll do, I won't do any more live coding. I can go through the one I produced earlier, which I actually did put the check in and just return an error here. And then for the add person handler, I did something similar where I've got the person store. I've realized I've copied and pasted the wrong code here. This is the add person. This is the find person again. So I can open up my example. Bear with me. I'll just leave presentation mode. So this would look like this essentially. Which is, sorry, I've copied the wrong one again. It's this one. So we've got this add person here. So this would be bound to our post, and what we would do is we would get the JSON as from the body. Routing context enables us to do that very easily, and we've got the JSON representation of the payload, and then we would just call our add, and then we can end back. So those are the handlers. And I realize I'll go back to presentation mode to show you that. This is what should be on that slide. Apologies, I pasted the wrong one. Once we've got the handlers, we obviously need the routers and the bindings. So very easily, this would be in our vertical. We would add the person, create the add person handler, inject the person store. Same for the get person. We create a router. We need to call this line. Vertx just needs this to set up the body handler. And that means that on line 22 here, we can call, we can get the JSON a bit easier. And then on the post, we would, hold on, sorry. On the post, we bind that to the add person. On the get, we bind that to the get person handler. And then to deploy it, this is something I haven't gone through maybe. We have our verticals. They wrap up, as I mentioned earlier, into a Vertx server. We can create a person store here. That should probably be created on the vertical, strictly speaking, because it is, yeah, we're not necessarily thread safe out here. we can deploy as many verticals as we want within a Vertex, and I think it's out of scope for this session, but you can then use the event bus to communicate between them. And then I just wanted to quickly go through, you can also use Vert.x to do integration testing. And not to just keep blindly throwing code at you, I can talk you through this one. Vert.x does servers as well as clients. So we can set up a REST client, set up a WebSocket client. Like it supports a lot of protocols. But in this example, I'll create a web client. I can create a person here, so just using that Pojo. Again, JSON, we use JSON. And then I can just post that person by using these buffers. So I guess I haven't gone through that too much in this session. Vertx uses a lot of buffers because it's going over the network, especially when you're pushing large amounts of data. So it's an efficient way to transmit it. So I just JSONify that, and then I've even got a handler here which I've implemented inline, which tells you whether it's a success or a fail. So this is the client side. Obviously, I would need this side running because it's an integration test. And then once I've got a person in there, you could query to check that it's there. And so the purpose of this test is post it, check that it's in the person store, and check the APIs return it correctly. So here I just create another request, get request on the API person, add the query params, and then inside the handler, I then just do an assert equals. So yeah, this means you can do a lot of stuff within Vertx. You can integration test. Yeah, you can do other things with the client as well. You could poll, you could fetch data in another vertical. You could delegate out to another REST service. Obviously, that would be quite slow, but it is possible. Cool. So just to summarize, we've gone through how to build a REST server. We've flown through it quite quickly. The key concepts are routine, handlers, and verticals. And handlers is where the bulk of your business or business glue logic would sit. Actually, I think this is wrong. It's probably the 5th or 6th time I mentioned it. Never block the event thread, otherwise you won't be able to scale your server. Vertx does much more than what I've explained here. I've just scratched the surface. So it has functionality for WebSockets, as mentioned, SockJS, other network stuff. It's really powerful. And you can use these components to build really advanced, scalable, enterprise-grade architectures. Feel free, please visit the website. It's got a lot more knowledge than I have, and it's got some really good documentation. I think we're out of time. Any questions? I don't know.
Hi, Adam. This is Anthony. I'm just covering up for Barry. First of all, many thanks for the brilliant presentation. Everyone can make questions in the chat, or if you want to show your appreciation, it's very welcome as well. And just to let everyone know, someone from LJC will make the recording available in the future, okay?
Okay. Cool. Okay, cool. So if there's no other questions, thank you so much for listening. Yeah, and if you've got any feedback or suggestions, please reach out to me. Yeah, this is my first presentation with LJC, so more than happy to take feedback on board. And I hope this was useful. Thanks very much, guys.